Welcome and thank you for attending our webinar on the topic of demystifying AI and machine learning for security operations. This is a collaboration between Google and Corelight. I'm Greg Bell, one of the co-founders of Corelight and also Chief Strategy Officer. And we have truly outstanding guests today. I'm looking forward to a very lively discussion and we appreciate your participation as well. It occurs to me that all of us on this webinar have lived through a remarkable year in the security space, in part because the discussion around AI really turned on a dime last year. And for me, maybe one of the most vivid moments was during a customer advisory board last March. The execs were presenting a number of topics we thought would be interesting to some of our largest customers. And a security leader in the financial services sector strongly challenged us to think about the beneficial uses of these newly emerged LLMs. And she revealed that her team was already using LLMs to accelerate SOC workflows and to analyze the data that our products generated just a few months after their launch. And that was kind of a wake-up call for us. And frankly, we haven't stopped thinking about the applications of newer AI techniques since then. All right, so we'll get into that topic and many more. Before we start, two quick points of order. This conversation is being recorded and you will be getting a link after the webinar, and there will be a Q&A session at the end. You can submit questions anytime through the interface to GoToWebinar. So if you have a question, we may not be able to address it immediately, but please submit it and I'll take a look at that and we'll try to weave in a number of questions toward the end before we close. Okay, without further ado, let me introduce our two guests. Umesh Shankar is the Chief Technologist for Google Cloud Security. He leads many cross-cutting initiatives, including the GCP security AI efforts. And in fact, Umesh has a history of taking on formidable challenges in his 17 years at Google. For example, he created the data protection effort at Google, building global infrastructure for key management, authentication, authorization, insider risk, supply chain security, data governance, access transparency, for which we thank him. And he previously led the Google Assistant ecosystem team, including its developer platform, identity monetization, and discovery services. Umesh has a PhD in computer science from UC Berkeley and an AB from Harvard. He is also an avid soccer player, mixologist, clarinetist, husband, and dad of 3 boys. And Umesh, this is a different webinar entirely, but someday we should talk about LLMs and mixology. That is sort of my personal Turing test, and that was one of the first challenges I devised for early GPT iterations when they launched. Our second guest is my colleague, Vern Paxson. Vern is co-founder and also chief scientist at Corelight. Corelight is a network security company that commercializes open source software that Vern invented. He's also a professor of the graduate school at UC Berkeley and formerly held staff and leadership positions at the International Computer Science Institute in Berkeley and at Lawrence Berkeley National Lab, where I first met him. At Corelight, Vern leads a team of about 20 researchers and developers who create high-performance algorithms for finding and contextualizing internet attacks. He's received a bunch of honors, including ACM's SIGCOMM Award for Lifetime Achievement, the Grace Murray Hopper Award, the IEEE Internet Award, and the Facebook Internet Defense Prize. So the bottom line, we have two fantastic guests, and I cannot wait to hear their perspectives. And I think we'll start approaching this complex topic by setting the stage a little bit definitionally. So Umesh, can you help us understand the meanings of the terms that we're going to be using today, including AI, ML, and LLM?
Sure, I'll take a crack. You hear the terms AI and ML often used interchangeably today. And so to some degree, some people might refer to one thing or the other when they use the terms, but generally speaking, when we refer to artificial intelligence, it refers to sort of the pursuit of human-like intelligence embodied in a machine, to be able to do tasks in the way that a human might do them, or at the performance or beyond of what a human might do. And you could use a variety of techniques to achieve that. One of the techniques that's commonly employed is machine learning, which tends to refer overall to a little bit more focused problem of saying there's a particular task, Something like classification is a very common one, and you want to teach the machine how to do it. And typically that involves feeding it lots of data to train it. Those could be, just examples of data. It could be unlabeled examples of data. But essentially, you're training the machine to do a particular task for you. That might be with the goal of artificial intelligence, or it might not. We've been using ML techniques in security for a very long time for things like spam detection, which was not in the pursuit of human-like intelligence exactly. But you often see that as one of the key techniques. And in fact, we're going to talk about today with LLMs, sort of at the intersection of those concepts, where an LLM, or large language model, is called large because it's a neural net, effectively, which has billions or even up to hundreds of billions of parameters characterizing it. So it's quite large. It takes a lot of compute resources to run such models. But they are also the product of machine learning. So in order to build such a model, which many of you may have interacted with in the form of smart chatbots, which are able to take some text and essentially figure out what the next text should be. In order to build such models, you need enormous amounts of data, enormous amounts of compute to do the training. Once you've built that model, you can use it for all kinds of purposes. One of the key innovations that led to the creation of large language models is what's called the transformer architecture. This was a technical innovation, actually, that came out of Google research. And the key insight there was by allowing the machine to attend to different parts of the input, it was much better able to process natural language in a human-like fashion compared to earlier architectures. And so it could disambiguate words in a sentence, for example, like if one word referred to another word in the sentence, it's better able to attend to that, or to stitch together concepts that may be at disparate points in the input. What we're seeing now is that LLMs are being used for a variety of things. I mean, almost every application and domain that's out there, people are trying to see how they can be brought to bear, and security is no exception.
Great, thanks, Umesh. It's surprisingly difficult to define these foundational terms crisply, so we appreciate that. And let me pop up a few layers and just ask a little bit, since you're at Google, about the prioritization of AI generally at large companies such as Google. It appears that a lot is going on, but I'd love your perspective on that.
Yeah, I mean, I don't think it's too much of a stretch to say that we're in some ways betting the company on AI. There is not one part of Google that has not been impacted, changed, affected by the development of generative AI in particular. Of course, Google has been doing machine learning and AI in various forms for a very long time. But this revolution has affected Google as much as anybody else. And you're seeing it used, in search. If you use the search generative experience, for example, you can see it in, Google Docs, stuff that can help you write or do research. And for sure, in the cloud space and in the cloud security space in particular, we're looking at applications across the board for, detecting attacks, for helping people process and understand large amounts of information. A lot of the things that are challenges for actual people in the practice of security every day.
Yeah, thank you. Vern, I'm going to turn to you, and we're going to narrow down the focus a little bit, because your career has in part been related to the history of detection and the uses of various techniques for detection, including ML, even before the rise of LLMs. So I'm curious if you could provide some perspective on that history of attempts to use AI and ML for security before, say, the rise of the big public LLMs.
Sure, yeah, happy to. The way I think of it, the real origins go all the way back to anomaly detection efforts, which were statistical, not really machine learning, but relying on techniques to mine large amounts of data to try to find patterns and then identify interesting deviations from those. Already 20 years ago, machine learning classifiers that could take large data sets that were labeled with either this example is something you're looking for or this example is something you're not looking for, could get very good at telling the two apart and detecting things like spam, like Anish mentioned, or bad URLs, or credit card companies would use it for possible fraud. And that was a successful use of machine learning that continues today to be quite beneficial. That said, I've long been cautious about using machine learning, and in 2010, I co-wrote a paper on, hey, this problem is hard for various reasons that I'll sketch in a minute, but I would say that 10 years later, in 2020, the paper was recognized with the Test of Time Awards. These really are the sort of key challenges for using machine learning for security. And I would call out three of them in particular. One of them is, I mentioned if you've got a large amount of data and it's labeled with this is what you're looking for, this is what you're not. That's hard to get. It's hard to get the data where it's actually rich enough. In particular, to get in for security, you're often looking at the details of what activity is going on, what people are doing, and so forth. And it's hard to get that data correctly labeled about all the non-attack things that are happening. So that's a big challenge. And if the data is not labeled well or not sufficiently large, it doesn't generalize. You don't have an accurate detector. The second is that a lot of machine learning is quite good at telling apart two different types of things if neither of them is super rare. And with attacks, they, in terms of the volume of data, they're super rare. So you might look at 1 billion events and one of them is bad. That's very challenging for lots of forms of machine learning. And the third is something we'll probably return to as we talk more about LLMs, is the challenge of explainability. You want to know why your detector finds something or doesn't, so you can build up a mental model of what to expect from it in the future. And that has proven challenging, but there's been a lot of advances in that. And I'm, while I was very cautious in, 14 years ago or so, today I see lots of promise, as well as still these challenges do remain.
Yeah, great. Let's, maybe we'll unpack that transition in your own perspective from caution to maybe a little optimism, because I think I'll stay with you for this next question. We are going to talk in this discussion about potential hazards of AI. There's a lot of interest in that topic. But right now, I would like to ask you both to focus on some positive impacts that you think AI will have on security operations in the near term. And Vern, maybe it's a good moment to extend your observation that your own perspective changed. So do you have any thoughts about positive future impacts of AI or present impacts of AI on the SOC?
Sure. I mean, I think when the LLM sort of exploded about a year and a half ago, I guess it is at this point, it was fascinating and a lot of, gee, what can they do? What can they not? Something that became clear, I think, quite quickly is user interfaces are never going to be the same. The LLMs are so helpful at bridging the gap between what a user, an analyst wants to, how they want to express things and how it actually has to be expressed so that, the database can be queried or whatever. They're great at that. And they're very adept at the opposite of taking the output of the search or whatever the thing is and presenting it in a more digestible fashion to people. So that is great. I think also the generative aspects, while there's some cautions about, how deep is the understanding of what you get, it's terrific as a way of getting drafts of something. Here's a starting point that the LLM can generate, and now you can work on it. And in particular, we've found that so our company, you know, we're rooted in open source technology, and we found that there's a dividend of that comes out of the large language models having trained on these enormous corpuses of what's out there on the internet. Is there's a lot out there on the internet about open source technologies, and an example is we've been able to leverage that the LLMs know quite a bit about Suricata, the signature engine that we use and many other security companies use, and because they've been exposed to a lot of materials about it, the LLMs with not too difficult prompt engineering can explain, for example, what's going on in a Suricata rule. So all of that is just terrific for sort of lowering the bar for analysts in terms of making their interactions more fluid, more effective.
And just to be clear, it sounds like the difficulties you identified in that 2010 paper still remain. They haven't been totally solved, or maybe at all solved, by the emergence of LLMs. Is that right?
Yes, sort of. I mean, so one of the things I framed was you need a lot of data at scale that's labeled. And what is exciting but also mysterious about the LLMs is they don't need the labels. They just figure out the correlations that are latent, that are hidden inside. But that comes at the cost of that other tension I framed about explainability, which is how do you know what it LLM knows and what it doesn't know? And I think the needle and haystack problem is still really quite challenging. I think LLMs changed the fact that 1 in a billion thing is difficult to train to find because it's just so rare.
Okay, thanks. I'll put a pitch in for that paper too. For people who haven't read it, it's brief. It's largely non-technical. There's no math in it. It's a good read. And with that, Umesh, I'm going to pass the baton to you to think a little bit about your perspective, or perhaps Google's, on the optimistic take on AI, especially in the context of security. What do you think about that?
Well, I won't presume to speak for Google, but I can certainly speak for myself. I think what's most exciting to me, I think Vern touched on some of the human-computer interaction implications of this, which I think are going to be many, and I think that'll be great to touch on later in this webinar as well, and how that relationship will evolve. I think it's going to be quite different as a result of LLMs. But what we're also seeing already is what truly transformational capabilities come out of LLMs in certain domains. Like, I think, Vern mentioned Suricata. In general, code and open source formats and so forth are things that they tend to be good at because there's a lot of it on the internet. And, when you're doing unsupervised learning with a lot of data, it tends to be good at the things where there's a lot of data. And so just to give a very concrete example, we have a new Gemini Pro model, which has a 1 million token context window. So that essentially represents a massive expansion in the amount of data you can feed to the model at once. The early LLMs that we saw 18 months ago, they were like 4K tokens, right? So like that's roughly like 12,000 characters-ish, which is, you can put a decent amount of stuff in there, but you can't feed it like a whole program or something, right? But with 1 million, now you can. And so one of the co-founders of Aristotle, Bernardo Quintero, who works at Google now, of course, he was looking at what could we do in terms of malware analysis using LLMs, and in particular, these very large context models. And so he went back and he said, all right, let me look at the WannaCry binary. So WannaCry was one of the most virulent worms that had been created. And fortunately, I think 6 or 7 hours after it kind of got out, some researchers were able to analyze it and figure out that there was a kill switch hidden inside, that if they registered a particular domain, could actually help stop the spread of the worm. And they did that, and that probably reduced by an order of magnitude or two the impact that the worm had. And so this highlights the speed of analysis and response really does matters to people. And so when Bernardo took the WannaCry binary, disassembled it, decompiled it, fed it to the 1 million context model and said, tell me what this does. Is it bad? Tell me some properties. It was able to correctly analyze the entire thing, say that it was probably malicious, talk about some of the IOCs associated to it, and in particular, identify that kill switch domain proactively. And it did this in, I think, 37 seconds. Right, so that's pretty incredible. That is a material advance that we just did not have the capability to do before, and we have the capability to do now.
I just have to interject. That's an awesome story. I really like that.
Yeah, it's a very late breaking story too. So it's kind of fun to be able to share it here. But I mean, this stuff is like, this is a big deal. This will change how we do a lot of security, right? That's been our biggest thing as defenders, is often like the inherent asymmetry of attack versus defense. Anything we could do to bring defense, closer to real time, like if you have a 0-day vulnerability, how quickly can you understand it, respond to it, develop defenses against it? We think that there's legitimate, real potential here. So I think that's very cool. To come back to the how to use it part, I think the user interface thing for sure is going to be different, and I think there's a potential for actually having dynamic user interfaces generated by the model that shows you things in the most useful view relative to what you want. We haven't quite gotten there yet, because I think for various engineering reasons and UI framework reasons, but there's no reason that we couldn't do something like that. And I think LLMs actually help us achieve that over time. That's a speculation, but I think there's some legs to it. The other thing that we think about is not just thinking about LLMs as a chat vehicle. Of course, they can do the binary analysis that I just mentioned, but really something that is infused into the product. So when you just use a feature of the product, the way that it does it might employ an LLM in the back end. So I think we're going to see both modes of usage, one where it's directly user impacting and interfacing, and one where it's under the covers, but doing some hard tasks that, it does better, faster than we would have otherwise been able to do.
Yeah, thanks for sharing that remarkable result. And the idea that LLMs could alter the user experience based on what they want to call attention to is pretty remarkable. In that case, you could have a please register this domain button, and obviously the LLM could probably go out and do that as well. You could begin to close the loop, since time is of the essence, as you point out. Okay, let's actually extend some of those comments and turn our attention to potential roadblocks that might prevent broad acceptance of AI in the security space. And with the sketch that you just conveyed, Umesh, one of them I think is probably going to be about just the human acceptance and trust. And I'm assuming you think about this quite a bit, how customers of Google's learn to trust products that feature AI. How do they understand when AI is or isn't at play, and how it's at play, and what the boundaries and rules are, what are the new rules of the game? And I'm wondering if you think the average security practitioner today has that kind of trust, and should he or she have that kind of trust? I assume this is within your mandate at Google to wonder about these questions.
Yeah, absolutely. I mean, people who use our security products expect them to work accurately and make correct representations about, their estate or about threats and so on. So accuracy is something that we take very seriously. LLMs, because of how they're trained, which is a lot on human-generated content, actually, are also vulnerable to some of the problems that come with that, because humans are fallible, right? So we see this pretty frequently that, Vern mentioned the difficulty of having clean, well-labeled training data, right? So even though you have kind of a lot of unsupervised learning, unlabeled data going into LLM training, there's also a fair bit of somewhat labeled data goes into like instruction tuning, So when you're teaching it to do a particular task, rather than just complete a bit of text, you need some canonical sense of, okay, here's the task and here's what a good answer looks like, and it can kind of learn from that. Conversely, when we think about things like benchmarks and evaluation to measure quality, the things that you ask it to do, like the actual benchmark needs to be extremely accurate as well, because otherwise you can have some skew. And we find all the time that this is a challenge, right? So getting kind of golden prompted responses, whether it's for instruction tuning or whether it's for evaluation, anytime you have an error in there, that can have ripple effects through the system, right? So that is the thing that I think is going to be really important for trust, is just getting those processes to be very, very clean. I think is going to be key for trust. But the trust, I think the trust is going to have to be earned, just as trust in a human would have to be earned, right? As the technology produces verifiably good, correct answers consistently over time, that's where the trust comes from. And I think we're at a stage now where, we probably can't just hand the keys over to the technology and expect it to, I certainly wouldn't. But we're at a stage now where I think it can do a lot for us. We need guardrails around how it operates. We probably don't want it to be able to actuate too many things without a person making sure that it's the right thing to do. But I think as the technology matures, gets more precise, and we have data over time to suggest like, people were saying approve 99.6% of the time to what it suggested we should do. Okay, maybe now then it's time to let it just do it, right? So I think that's kind of where we are in our journey. In our own thinking strategically, we use this autonomous vehicle analogy a lot, from manual all the way at one end, fully autonomous at the other end, where the inside of the car looks like a living room and all these I think very humorous renderings. We're somewhere in the level 2 assisted thing, which is like the equivalent of like the lane departure warning and the automatic cruise control and some nice features like that. And there are things that kind of assist you in your journey. That's often how we're seeing Gen AI applied today. But we're targeting is that middle zone between that and fully autonomous. We're calling it semi-autonomous, where the kind of churn of the life cycle management of a process that a person has to go through, which can often be very tedious and painful and monotonous, that life cycle could be taken over by the technology, but the person is still pulled in for key decision points where they have to render judgment, or the technology doesn't know how to do something. So that's kind of where we think it's reasonable to try to target over the next few years.
Yeah, thank you for pointing out, that the trust question doesn't end with our relationship to AI models, but it extends to other humans. It's sort of a fundamental part of the human condition. And I think the metaphor is useful too, and especially to people, especially meaningful to people who live and work in cities where fully autonomous vehicles are on the roads or been on the roads. And what we find, I think, is a wide variety of human preferences with regard and trust levels, and that's probably going to evolve rapidly. Vern, let me move on to you and ask a different question about trust, but it's one you've already alluded to, which is this sort of baffling disconnect between input and output for some of these models. So we know what we give them, we know what they say, we don't always know how it works in the middle. And as a person who's spent many, many years developing leading algorithms for identifying malicious activity, I'm curious how you think about the challenge of working with tools when that relationship between input and output can't clearly be explained. So how do you learn to trust those tools? How does your team, the researchers on your team, learn to trust the output of ML?
Yeah, it's a great challenge. And I think of it in sort of two ways. There's, do we think it really gets it right? And then there is, why is it getting it right? And they're both really valuable. Do we think it's getting it right? Sometimes just boils down to, let's do a truly random sample of tasks we give it and manually analyze them and put in that effort to say this was the actual correct answer. And if the model's nailing it and getting it almost all the time, great. And actually some of the best results there are when you think, no, the model didn't get that one right, and then you realize, oh, it actually did. I didn't get it right. That really, if you can get that level, you get a lot of trust that the model's powerful. You can also sometimes accelerate that process by coming up with some different way to detect the same thing that maybe is really expensive and so forth, but you'll still use it as a cross-check and see when do they agree, when do they disagree, and what do you think about the disagreements. Going to the deeper question of how it can be so important, because it's amazing how diverse the environments are where you deploy detection technology, at least in some domains, right? For spam, okay, that's not so diverse. It's spam, different email providers likely looks pretty similar still. But for like what we do, analyzing activity, detecting attacks inside enterprise networks, one enterprise network can be vastly different from another. It's surprising how different. And so you want to know, how is the model achieving good results in the data you gave it, so you can think about how is it going to do in a different environment. And for that, a powerful approach is to, some models, first I should say, provide this up front. So you can just look at their weights and so forth and identify it. But for others, a powerful approach is to shortchange the model, tell it, okay, I'm not going to give you all those features. I'm going to give you a bunch of them, but not all of them. Let's see how well you do with that. And if the model does just as well, then you know the features you held out don't really matter. And if the model doesn't do as well, you're like, oh, those features matter. And so you can develop, I actually call it kind of an intuition for the deeper, more complex models of what's going on by feature holdout. And then a final technique that's potentially interesting is you can take a deep learning model that is opaque, and if you've convinced yourself it's quite accurate, use it to label a bunch of data, and then train up an explainable model on those labels, and then look at the explainable model to see, oh, it's using these features and those features. That must be related to how the more powerful model works, even though you can't directly investigate. So there's a bunch of technical approaches, and it's an important art and skill for those who are developing these algorithms to really nail, because it goes right to the heart of, do you trust it? Is it sound? Is it something you want to ultimately get actionable information out of?
Yeah, it's almost like your team is probing these models. We came from a high energy physics environment, so they're probing them kind of like an accelerator would, disturbing them, perturbing
Black box.
them.
Yeah,
It's pretty cool.
Poke it, see what happens.
Yeah, it's an LBNL thing. On the workforce, have you seen your team rapidly develop these skills? I mean, how did these skills, it seems like the team has discovered, and maybe a lot of teams are discovering these skills simultaneously. What's happening there? Are you hiring different kinds of people who are curious in this new way, or are existing team members evolving to
it's some of both. There's of course a whole ton of interest in data science and machine learning. You get lots of prospects who are trained in that, and what we find is A, great that they have good chops, but B, it gotta really find the security domain interesting and worth the headaches. And the domain does have a lot of headaches, and the particulars of the domain are different than maybe what somebody who just has a general data science background is used to. It's sort of the rareness of events that you care about, all the diversity in different environments, all those things. And so they got to like that. Because it's a pain if you don't like it. I mean, it makes extra work, and so it's that combination that you particularly need.
Yeah, that's the sweet spot. You and I have often talked about the weirdness of real networks and the strange, almost unexplainable behavior of certain hosts.
Yeah, it's like emergent behavior almost.
Yeah, yeah. All right. Well, this is a good transitional point, I think, to begin to explore the other side of the coin. We have been thinking optimistically, and we've been thinking about the powers, various powers, and surprising powers of these new models and techniques. Let's think a little bit now about the hazards, the caveats, so that we use the tools mindfully and appropriately. And as they begin, especially as they begin to be incorporated into security workflows, they begin to be trusted a bit more. So maybe I'll start with you, Umesh. If you can provide just a little bit of advice and reflection on what hazards and caveats we should still be on the lookout for.
Yeah, one problem of LLMs that you hear a lot about is hallucination. And when people say that, what they mean is the LLM output some text that was not true.
Mm-hmm.
Typically, that's what they mean. And what's really tricky about that is you can ask an LLM to write a story for you, and that's not true.
Mm-hmm.
So on some level, right, I think hallucination and creativity are kind of just two sides of the same coin.
Mm-hmm.
And one of the challenges we have with the LLM is it doesn't have this factual self-knowledge. It's just been trained to emit, tokens. It doesn't intrinsically know these facts are true, these facts are not true. Here's the sort of known unknowns in my set of knowledge. And so I think, intrinsically, it is not, that's where we're at today, right? Is that these things will just happily, if you ask them to tell you about CVE, 2025 dash whatever, they'll just like tell you something, right? Could be real. And what we found is you need to invest in grounding to avoid that problem. So I think certainly I, and maybe many others, we started down this road, whatever, 18 months ago. We're thinking, oh, the capability is in the knowledge that these LLMs have. But actually, you can't rely upon it to regurgitate any specific fact, information, or to know when it doesn't know information, right? Even if you've trained it on that exact thing, you can't rely upon it to recall that in order to respond to a prompt. So really what you're relying upon it to do is understand what you're asking it to do, have the reasoning capabilities to put together a response. But if you need it to rely upon a specific fact, you have to supply that fact in the prompt itself. Right, and so, I mean, the concept of grounding goes way back, even to, natural language understanding and semantics and whatever. But just the idea that if there's a concept being referred to, or a word, you ground the reference of that word to a specific actual entity or definition. And so that is a technique that we found is really necessary if you want to avoid this. So if you're going to talk about a particular, let's just use the same example of vulnerability, then you need to go have a canonical source of truth for those concepts and entities and go retrieve that canonical information and make sure that the LLM has it right then and there and say, okay, rely upon this in formulating your answer, even though it may have been trained on it or not. So that to me is probably one of the biggest challenges in insecurity, where people depend upon us to give them good advice, good answers. It seems a particularly acute thing for us to get ahead of.
Yeah, and gosh, I guess if some of us have probably experienced these really super confident hallucinations from LLMs, and if you haven't, if you've only used LLMs to write, the first draft of a toast at a wedding or something like that, you should maybe explore, explore the edges of the validity of their output, because it can be really surprisingly super confident and utterly wrong. And I guess, Umesh, the workaround that you helped us understand, it really underlies the importance of having a model that can accept a lot of tokens, right? Because the more factual content you can supply as part of the question, the better. It sounds like the less likelihood of hallucination.
Yeah, for sure, that absolutely plays into it. And I think even just the concept of a raw LLM as a technique is going to become less the only focus. I think we're going to see more kind of compound reasoning systems which combine LLMs with these canonical sources of truth and particular documents which may be private, that you want it to rely upon. So I think that if I'm going to prognosticate a little bit more, I think that's kind of the direction we need to head in order to get useful results.
Mm-hmm. Yeah, it sounds like we're heading towards a toolkit architecture where LLMs are composed, and there are other tools as well in the mix and pipelined. Vern, what are your perspectives on sort of the hazards and caveats of using LLMs now that you've really had a lot of operational experience with our product line?
Yeah, the main things I think about are from the perspective of those who are going to draw upon the technology. The LLMs are mysterious and clearly powerful, and I think there's a tendency to think they're all powerful. And so, it's just the basic reminder, there's no silver bullet, that they, in fact, as Mesh, you were just saying, I mean, they don't know things. They just are very good at putting together, a bunch of context around something or the like, or generating something, but they don't actually know it. And so I'm struck by the amount of, I'll just call it hype over LLMs. It's amazing. And you can understand where it comes from, because it's clearly a capability we just didn't have a few years ago. But where are the boundaries? And as a consumer of it, it's difficult to know. So the thing I would flag for those consumers is there are real limits, and heed that. And the other that intrigues me somewhat in terms of we're talking a bunch about how do we accelerate the productivity of analysts and so forth. There have been studies, user studies over the years, over the decades, about this interesting phenomenon, which is if a user interface provides certain types of feedback too quickly, the analyst actually switches in their thinking to more of a sort of hunt around and poke, and they don't step back and reflect on what's going on and make the higher level connections. And I think that that's just something to keep in mind as we give these analysts these power tools, which are great to have, that we don't block that need for the analyst to also be able to just have to sit there and think, because sometimes that is really ultimately where the value is. So it's great helping them get to that point, but then you want, once they're at that point, that there's space for that contemplation, as opposed to, there's yet another thing, another button to push to move along. So I find both of those, they're in some ways basic, but in some ways useful to reflect on. They're not all powerful, and beware of power tools. Sometimes, everything looks like a nail because you've got this great hammer. Yeah.
Construction, I think, provides many examples of power tools leading to wildly unfortunate accidents. So we'll try to avoid that. I'm sure that same, you called it space for contemplation, I'm sure that same concern actually is arising in all sorts of domains, not just security, but in law and radiology and all sorts of domains that are being transformed by AI at the moment. All right, this has been a really great conversation, and with an eye on the clock, I want to get time for questions. So I think what I'll do, I'll ask everyone in the audience to please share questions that you have through the interface that's been provided, and I will ask our panelists to just to answer one more question, maybe in with a couple at the level of a couple minutes each. And this is really a chance to provide some personal reflections But I'm curious what has been especially surprising to each of you about the sudden rise in AI technology, especially LLMs. And Umesh, from your perspective, it may not have been so sudden. You may have anticipated what the state of the art was and its application to security. For most people, it's been super surprising. But nevertheless, I'm sort of curious what has been especially surprising to you in the last 18 months or so.
It's hard to pick, one thing because there's so much activity. I think coming back to the theme of these LLMs being good at writing and reading code, I think that there is, and now that they have these other kind of multimodal reasoning capabilities, you combine that together and it's very powerful, right? We're already seeing a bunch of activity in this space where saw someone do posted something, I think actually it was someone from Google Research, that she had gone to like a real estate website and took a screen capture of her using the site and then said, write me some web automation that will just like do this for me so I can run the search periodically. And it did it. It watched the video and it wrote the code to do what she needed it to do. I mean, I've seen other demos where someone literally would draw the interface of a mobile app and roughly, sort of said what they wanted the app to do, and it made the app. Right, so I think that there could very well be a democratization of the ability to develop and create, which I think is wonderful for the world. It's something where I've thought about it in another context where it's like, for those of us for whom coding is just like a natural thing, for code since I was a little kid, the computer is a malleable, mutable thing. Yes, you get some package software, but if it doesn't do what you want, you can make it do what you want, kind of, right? And for people who don't have that ability, then it's not like that at all, right? It's sort of it's more opaque and fixed function, and you just can't get it to do what you want it to do as easily. Now, in other domains, I'm not like that at all, and I feel probably the exact same frustration as someone who is just like, oh, I don't like my house, I'm just hanging some drywall and like add this wall here, do whatever. That would not be a thing I would just like spend a weekend doing because I don't have the skill. So I think, to me, that is one fun area, not about security really, but something in this space where I think it is going to be transformative.
Yeah, so the democratization of a capability that's been really just an elite skill set in the past. It's sort of amazing. I've seen those demos too, and I found them surprising at all. It is remarkable. Brendan, what about you? What has surprised you about the past 18 months and what's been revealed about LLMs and AI more generally?
Yeah, well, first I'd say, Umesh, again, I love that example because it is such a striking change. And it reminds me of when I was first interacting with, I guess it was ChatGPT. And there was part of my mind like, they're cheating. They've got some pool of people who are fielding these queries and, quickly searching the net and whatever. So that sense of how much knowledge was inside the model was amazing. And then the flip side of it was how incredibly superficial some of that knowledge is, and you can't tell them apart. It goes to the hallucination thing. So the fact that the models are so opaque does just drive me nuts, because I've always been emphasized in my research. It's not okay to get the right answer if you don't know how you got it, because the real understanding and knowledge comes from the how you got it, not the answer itself. And so that just remains for me something that I'm intrigued with, bugs me, but also really intrigues me. That this whole tension of how we're going to leverage the fact that we don't really know the depth of the knowledge. And I think over the coming years we'll come up with a whole suite of tools in the toolbox for developing that confidence. And boy, do I look forward to that.
Yeah, thank you. All right, for folks watching, this is your chance to ask a question for Umesh or Vern, and type that out now because I will happily convey it to them. And if you don't have questions, I will use my license to ask one. So this is admittedly sort of an impossible question, but I wouldn't mind hearing each of your perspectives on a topic that's often discussed in podcasts. It's on a lot of people's mind, and it's about the balance of good versus bad impact in security generally arising from LLMs. I mean, all great technology achievements, right, have both, like they impact on both sides of the coin, and sometimes the implications aren't clear. But to the extent that you could see, I'd love for you to give us a blink on whether this is mostly good for defenders or mostly bad for defenders, especially, and also whether that that judgment might change in the next couple of years. So Umesh, I'll toss this to you first.
Well, the truth is I don't know. I think some of the inherent and historical asymmetries between attackers and defenders are not going to go away anytime soon. You know, even if we're able to identify vulnerabilities as fast as attackers can, which would itself already be quite an advance. It doesn't mean we know how to make and deploy patches faster.
Yeah.
Right. So there are some of these underlying things, which, you know, maybe this puts more pressure on getting that to be better, and that's good. And maybe AI helps us roll out changes and fixes more safely and quickly, right? So I think, I certainly think it will improve things for the defender, will improve it more so than for attackers. It's hard to say, but you know, one thing I was thinking about here is that separates the two, right? Is besides this deep asymmetry, is that attackers don't have to play by any rules. There's no such thing as cheating. If you can do whatever you want to achieve your outcome. And in general, the defenders do have to play by rules. I mean, we're all subject to all kinds of laws and rules and regulations and so forth, and many of them are for very good reasons. I think now we're seeing with AI, you know, a lot of, you know, well-intended and in many ways necessary laws, rules, and regulations. But I think one thing that societally we'll just have to keep an eye on and be careful about is making sure we don't hamstring defenders' use of AI to combat attackers' use of AI. Right? There are cases in security where, you know, to run a red team exercise against yourself, you need to generate bad scenarios, threatening scenarios. You probably need models that have been trained on malicious code in order to fully understand and detect malicious code, right? And in general, because we are legitimately concerned about safety, we shy away from some of those things in our general purpose models. And so, and maybe forbid some of that, right, with rules. And so I think that's just something we'll have to, again, as a society, make sure that we create the space, just as we've had to have a lot of that space created in, you know, legally thorny areas for security researchers generally who are trying to probe and find vulnerabilities. We'll need to create that space for people to be able to defend effectively using AI.
Yeah, thank you. Vern, do you have a view on that? Or what's happened in the last couple minutes is questions have started flowing in, so we could start addressing some of those questions as well, unless you have something you'd like to make.
I have a quick view that I'd like to tee up. One is, it seems clear social engineering is going to get worse, and the generative AI is good at way better at quickly producing stuff that can fool people. So that one's a negative. I think that the benefits for defenders are also clear. I mean, I think this up-leveling of the analysts is going to be a big magnifier and just a huge plus. Just one thing I would add to the attackers not playing by the rules. Well, yeah, in general, that is a asymmetry that is challenging. Something that was interesting and striking from work I did earlier with colleagues on cybercrime is the realization that the bad guys today, they actually have a whole bunch of defender problems because they've got infrastructure they rely on. They've got the need to, deal with other parties who they only interact with remotely and so forth. So I think there's also some possibilities that LLMs may be able to help undermine cybercrime networks and so forth by finding infrastructure linkages or social linkages a lot more effectively. So one last thought there.
Yeah, no, thank you for that. We just have a few minutes remaining, so sort of in lightning round, I'll try to get to a few of these questions. And one of them is just a question for you, Vern. What's the name of that paper that you alluded to, the one that won Test of Time Award? I can't remember the title.
Outside the Closed World.
Yeah, Robin Summer.
There's some subtitle, I can't remember.
Yeah, so you can find that.
2010 IEEE Security and Privacy.
Yeah. We have this one is probably for you, Vern, too, and we don't want to make it into a commercial, but it's interesting. Since we're talking about Corelight Zeek generated data, is there an effective method, AI or ML, for detecting C2 traffic using data in the various logs, con, SSL, HTTP? What we do with statistical approaches, I think the essence of the question is it's not enough. So are there other approaches for detecting C2 traffic?
Yeah, so we internally, of course, thought a lot about how do we use LLMs best, and detection is not such an easy one for them. One thing that we've used neural nets for in the past, and I think LLMs will help, is actually to find social engineering. So I think that's the more apt detection problem domain currently, given the current capabilities.
Yeah, thank you. So Umesh, one for you, or for either of you, do you see AI being able to do something fairly high level here, to identify threats and vulnerabilities and generate the risk rating matrix and attack paths like the MITRE ATT&CK framework? And in a way, maybe it reminds me a little bit of your code analysis as an example, to start with an artifact and produce the broader context. What are the TPs? What is the risk level associated? Do you see that happening in the future? Maybe it's already happening.
Yeah, that is something actually we're actively already working on.
Okay.
Being able to analyze things, map them to likely threat actors. I mean, these are things that people have had to do anyway, and you want to do. Maybe we can do it faster, better, with like a fraction of the signal maybe that a person might have wanted or needed in the past. We do work with attack path simulation on cloud. Mm-hmm. And that's also an area where we're thinking, if you could actually get real-time signals about what was going on, could you map that onto, what of the graph of your actual deployment, and look for telltale signs or patterns that might be indicative of certain kinds of attacks or threat actors. So I think there's a lot of room to run there. It's still very early days.
Thank you. Here's one final question before we need to sign off, but it's a good one. Where can cybersecurity AI ML practitioners, where can they find community? Where can they collaborate as a community on strategic directions, use cases? I would be remiss if I didn't point out that the open source projects that Corelight is working to commercialize, Zeek and Suricata, have large online communities and Slack environments for discussion. I would really love to see more AI and ML related discussion in those contexts, but that's probably not the only answer for everyone. I'm curious, Vern and Umesh, if either of you have ideas about where interested parties can collaborate and share.
So, I come from academia, so that skews my view a bit, but there's, SecAI is a conference on AI meets security that goes back many years, and there are other such things. In addition, the influx of AI into security is now such that the just general security venues, using Security Symposium, for example, there's going to be plenty of discussion about AI-related themes, detections, LLMs, et cetera. But Umesh, you want to add to that?
I don't have a whole lot to add, honestly. What's funny is a lot of the place that people seem to have discussions like on Twitter, right? Or by publishing preprints, and the rate of paper generation is very, very high. And so I feel like a lot of the discussion is just happening in real time to some degree through those media, but I'm sure there are other forums that I'm maybe not the best person.
Yeah, I think that's a good start. So the answer may be it's going to be hard for you to avoid these topics in the future. Where you hang out, online or in person. And I think that brings our discussion to a close. I want to thank you as attendees for your participation, whether you watched live or on a replay. Thank you for your excellent questions. A big thank you to Umesh and to Vern for contributing their experience and ideas. Thank you to Corelight and Google for co-sponsoring. I will remind you, you will all get a link to this recording shortly. And if you're interested in learning more, you can visit our websites. You can attend Google Cloud Next. The digital registration just opened. We can meet in person at RSA, which is coming up surprisingly soon. So for now, we'll be signing off, but we hope to see you in person very soon. Thank you, Vern. Thank you, Umesh. Take care.
Thanks, a lot of fun.
Thank you.
Yeah, that's great.